6.02 times 10 to the 23rd formula units of sodium hydroxide is 1 mole of sodium hydroxide. Notice how this is set up so these will cross out so I know I'm doing things right. So I'd put in the calculator 4 times 6.02. In this calculator it's second function, then the EE button, and then 23rd. I don't put in the times or the 10. Press enter and I will get 2.41 after rounding. E24, 2.41 times 10 to the 24th, and the units will be formula units of sodium hydroxide. The next one down is dealing with trifluorine dioxide, F3O2. I'm starting off with 4.2 times 10 to the 23rd molecules of F2O3, and I'm getting ready to multiply by a fraction. I'm trying to get from molecules to moles. According to the mole map, if I'm going from the representative particle molecule to the mole, I put 1 mole on top and Avogadro's number on the bottom. 1 mole F2O3 on top, 6.02 times 10 to the 23rd molecules of F2O3 on the bottom. Molecules and molecules will cross out. Putting that into the calculator, 4.2 second function E, or times 10 to the 23rd, divided by, because this is on the bottom, we divide by 6.02 second function E times 10 to the 23rd. Remember, I don't put in the times or even the 10. And I will get 0.70 after rounding. 0.70. My unit will be moles of F2O3. The next one, calculate the number of oxygen atoms in 5 moles of phosphoric acid. We're starting off with 5 moles. Phosphoric acid, on the other side, we have already figured that its formula is H3PO4. H3PO4. Now get ready to multiply by a fraction. I'm trying to get from moles to atoms. Here's moles and here are atoms. So I know I'm going to be putting 6.02 times 10 to the 23rd particles on top and 1 mole on the bottom. 1 mole H3PO4, 6.02 times 10 to the 23rd. Now I got to think about this though. The particles that phosphoric acid is formed in, H3PO4, are formula units. Those are not atoms like I need to have. This ends up being a vocab mismatch. Since H3PO4 is built in formula units, the particle I have to put as a unit on top is formula units of H3PO4. If I crossed off this and this, all I would have done is change this into formula units. And what I really need to know is the number of oxygen atoms. So I have one more step. Now I can tell you that on this step, I know I'm going to have formula units of H3PO4 on the bottom. And in one formula unit, what I really need to know, that way this will cross off, what I really need to know is how many oxygen atoms. I need atoms of O, not O2, because it's asking about atoms, not molecules. Can you see that in every H3PO4 formula unit there are 4 oxygens? That means a 4 goes on top. Now that it's all set up, now I can use my calculator. 5 times 6.02, second function E, 23, times 4, enter. And I will get 1.2 times 10 to the 25th, 1.2 times 10 to the 25th power atoms of oxygen. Finally, the super duper challenge. Don't watch me do it until you try it on your own. Don't be afraid of the words super and duper. It really isn't that difficult if you know how to read a map. Calculate the number of water molecules contained in 10 grams of water. 10 grams of H2O. Get ready to multiply by a fraction. Now check the road map, the mole map. We're trying to get from grams to molecules. Here's the mole map. There's grams. There's molecules. You have to go through the mole to get there. It just makes it a two-step problem. We have to follow from grams to molecules, 1 mole over the molar mass, and then Avogadro's number over 1 mole. Let's see what that looks like. First things first, 1 mole over the molar mass. 1 mole of H2O. Now I need the molar mass of water. The molar mass of water, well, it's built of 2 hydrogens, 2 times 1 gram each of hydrogen, plus 6, it's built of water, 1 water, which is 16 grams. That equals 18 grams for a formula mass. Where did I get the 1 and the 16? From the periodic table. The gram atomic mass of hydrogen is 1. The gram atomic mass of oxygen is 16. The gram molecular mass of water is 18 grams. 18 grams of water. Now if I do that, that's going to allow me to cross off grams of water and leave moles. Realize what I really needed to get to, though, is the number of molecules. Let me go back to that road map where we were taking 2 steps. We just went from grams to moles. Now it's time to go from moles to molecules. Avogadro's number goes on top. 1 mole goes on the bottom. Truthfully, I think I could have predicted that 1 mole was going to go on the bottom, though, so this would cross off 1 mole of H2O. What I really needed to know is particles. Avogadro's number 6.02 times 10 to the 23rd. This will be molecules of H2O. This and this will cross off. Putting that into the calculator, 10. Now, I'm going to ignore the 1, but I'm going to multiply by 6.02 times 10 to the 23rd because it's on top. So 10 times 6.02, second function E, 23rd. But now I have to divide by all the numbers on the bottom. I'll ignore the 1, but now I'll just simply press divided by 18 and press enter. That leaves me 3.34 times 10 to the 23rd. 3.34 times 10 to the 23rd molecules of H2O. Make sure your paper is 100% correct before you turn it into Mr. K to get your practice test.